Hello everyone. We still have a few minutes before we start, and then we'll begin the next Blatchford's prosthetic product showcase webinar. But as I say, we've got another couple of minutes before we're due to start, so please just make yourself comfortable, get yourself a cup of tea or coffee, and we'll start in a couple of minutes. Hello everyone. So, as usual, before we begin, I'd like to point out that all participants are on mute for a better experience. This webinar is being recorded and will be made available on the Blatchford's website at some point in the future. Please use the question panel on the right-hand side of the screen as you go along with any questions, and hopefully we'll be able to answer them as we go along. Handouts are also available on the right-hand side in the handout section. Please feel free to download these now at a later date up from the website. At the end of the presentation, a webinar feedback survey will be given out. Please complete this and let us know what you think, what we can do better. Also, by completing the webinar feedback, I know that you require a certificate for your continued professional development or for your employer, so please complete these. Please also register for future webinars at blatchford.co.uk/webinars. And should you have any questions after the presentation, or if you think I need to supply more details, please contact myself, john.ross@blatchford.co.uk. Today's webinar is on shock absorption and rotation units. This webinar will be presented by myself, John Ross. I'm Principal Prosthetist with Blatchford's. I've been a prosthetist for over 27 years. I still practice prosthetics here in southeast London. And I have a keen interest in these. Actually, for some of you, I have presented and published papers on using similar devices to this previously, both at ISPO World Conferences, and have published papers on this type of device and with my interest in prosthetic care. I'm ably assisted today with our friend, Lee Boxall, and Lee uses such a device, but I'll let him introduce himself. Lee, over to you.
Hi, I'm Lee. I've been an amputee now since around 2004 following a motorcycle accident. I live in York in the UK, which is a medieval city with lots of cobbled streets. And I work from day to day as an artist and sell my work on a busy market in York. My day starts at about 6:30 in the morning and then finishes about 6:30 at evening, so it's quite a long day. And it includes building stall and loading, jumping up and down to set up the stall, and then standing all day on uneven pavements. In my leisure time, I enjoy long walks with my dog, Ruby, visiting the gym when it's actually open. And currently I'm also renovating properties during the partial lockdown. And I've now been testing and wearing Blatchford feet for about 15 years. Happy to be here.
Thanks, Lee. So today's agenda, I'm going to start off with a background on shock absorbing pylons, run over some of the details from before. I'm going to then talk about the TTPro. This is a shock absorbing pylon that we've had available for quite a long time, but is often forgotten about. But it still has relevant uses even today. I'll then talk about the EliteVT, the BladeVT, the EchelonVT, and then finish with a summary of the evidences and the conclusions. Starting off with the background. Shock absorbing pylons, commonly called SAPs, are not new. Probably the first reported use of this was the Terry Fox running leg. Terry Fox was involved in the Marathon of Hope, a 3,339-mile run over 143 days across Canada. The point of this marathon was to raise funds for cancer research and care, as this is the reason that he lost his limb. And it's probably the first time that I really have come across anyone mentioning the use of a spring for shock absorption in their limb. What was used for this limb and how it was done was actually then presented or described by Martel in 1985 at the ISPO World Conference. In the late 1990s, researchers started fitting torque absorbers to these axial compression units, and they started being known as shock torsion pylons, or STPs for short. In 2001, I presented our findings from London on using these for transfemoral amputees. And in 2003 at the OT World in Leipzig, I presented again on their use for K2 users and the benefits they gave to the patients. So STPs, shock and torsion pylons, and user benefits. When we look at the improvements in clinical outcomes using shock absorbing and torque absorbing pylons compared to rigid pylons, the first one we see is the improvement in safety, notably in reduced back pain during twisting motions for golf, for example, or anything, say someone's working at a bench and having to pivot between separate benches to complete their function. And this was reported by Rogers and Prosthetics and Orthotics International. We also see an improvement in mobility, illustrated. So this improvement in mobility, we see that even though we have increased weight and we have increased complexity, there's no added gait compensations, and the patients actually walk with a more symmetrical gait. And this was recorded by Bootwell and also separately by Stephen Gardner's team. Keys to these benefits of the STPs was a paper by Berg that showed the reduction in compensatory knee flexion at loading response. This is one of the main reasons for providing these to the older or less active amputee to hopefully reduce degenerative joint disease and its effect or progression for this group of amputees. And the photograph you can actually see here is a patient of ours from Southeast London up in the Crystal Palace Park. This is only a few minute walk from our office. What's also been seen is that there's no reduction in step activity with these patients. So even though the limb is slightly heavier when adding an STP as opposed to a rigid pylon, we don't see the patients decrease in mobility. However, what we do notice is there's an improvement in the residual limb health. Similar to my findings, GARD reported a reduced loading rate in the prosthetic limb. This is important as it gives the natural elasticity of skin time to respond to the applied load, increasing socket comfort and reducing the probability of tissue damage. Bootwell et al. The Prosthetic and Orthotic International found this was particularly relevant at faster walking speeds. So when we asked this group of patients to walk faster than their customary walking speed by 10–30%. Last but not least improvement is the user satisfaction. GARD showed that when we gave a range of prosthetic availabilities or components available to the patient, then the patient's preference was actually to have an STP built into their limb, citing the improvements in comfort, the smoothness gain, and the easier stair descent when using these type of products. So I'll start off with the TTPro. The TTPro telescopic and torsional, first thing, the TT pylon. So telescopic and torsional pylon. The telescopic gives us the axial compression or shock absorption in the limb, with a torque absorber element that reduces shear forces developed by twisting inside the socket during rotational movements, such as this boy here playing golf, or more commonly someone who's working in a tight space between benches and having to constantly twist backwards and forwards to get to the different objects. The TTPro provides up to 13 millimeters of telescopic, i.e. axial, compression, giving shock absorption, but also reducing the movement of the travel of the center of mass during rollover in the foot, i.e. the center of mass is not increasing and decreasing so much as the patient is supporting their weight on the prosthetic limb. This is going to save you energy because you're not having to lift that mass up and down. Coupled with this telescopic compression, we have a plus or minus 30 degrees of torsional rotation compliance. Okay, this is admittedly more than an able-bodied individual can get. We don't get 30 degrees of rotation, internal and external rotation at our ankle and lower limb, but the increased range meant that we no longer had to choose whether it was a left or right amputee, and we could do better with certain sports. The TTPro is a component designed primarily for K2, K3, and some K4 users, depending upon your reimbursement in that country. For K4 users, it would really depend on the sport that the patient is going to take part on. So if their sport was like cycling or skateboarding, yes, it would work well for it. But if I would use one of the later products I would talk about, if it, for example, was abseiling, depending on what the patient was doing. The devices are designed to cushion shock and shear forces and improve socket comfort. And whenever we think back to what patients ask for, it doesn't matter where the amputee is from in the world or their age, the number one thing they always ask for is comfort. Comfort is always a primary sought device for the amputees. The unit's ideal for walkers, dancing, which is a common use for it, hiking, camping, and any workplace roles requiring work at a table or bench, rotational pickup assemblies. I did work for a while with a rehabilitation engineer who believed that these devices were for golf, because every time he saw someone who had one of these devices, he said, "Do you play golf?" And they were like, "Yes." But they're not just intended for that. It can be anyone who's mobile or anyone who has degenerative joint problems with their remaining limb, because this will offload these problems. There's a weight limit of 125 kilograms for this device, and that drops to 100 kilograms for the K4 user. And as I said before, for those of you who don't know, this is actually one of our patients outside the shops next to our office in Crystal Palace, if you never had the pleasure of joining us down here in South East London. So how do we get this shock absorption? The vertical compression is provided by a coil spring. The reason we use a coil spring is it's much more energy efficient than polymer springs. The reason the coil spring is more efficient is because less energy is wasted by being converted to heat than a polymer spring. So polymer springs, if you're involved in a high impact, repeated movement, they will get warm, unlike the coil spring. The coil spring in the TTPro results in a superior toe-off characteristic as opposed to polymer springs, because more energy is returned. Springs store and return energy in a better way, and that's why they generate less heat. Also, if you look at the vector profile from this diagram here, note the dip in the middle of the vector profile. This dips less with the use of the spring than it does with a polymer spring, leading to less resistance to roll off. So therefore the patient will use less energy between heel strike to late stance as they progress along the length of the foot with the spring as they would with the polymer friction bumper. Studies have also shown that compression provided toe-off reduces the hip and knee movement and therefore reduces the wear and tear in the joints. This is ideal for preventing degenerative joint diseases in later life. From earlier webinars, you will have heard how amputees are twice as likely to develop osteoarthritis as their able-bodied population. And this is one of the main reasons that we believe that these devices are ideally suited to our K2 and K3 users, maintaining their general well-being and health. The gold-coloured bearings, which are now part of this device, are actually a ceramic titanium nitride coating. Okay, we use this to provide a super hard wearing surface for the moving parts, and the advantage of this is it gives a smoother ride in and out of axial compression, so the patient does not feel any sticking or juddering action as they're walking on it. The TTPro refers to the bigger bearing area with 20% improvement in this aspect. So the unit can now take higher moments and still work smoothly. Okay, so the bearing size has been increased. We incorporate seals that prevent contamination of the bearing surface, such as grit or sand from those golfers, getting in and rotate. And the other advantage of these seals is it retains the lubricant. So the unit only needs to be lubricated once a year during your average checkup of the patient and or servicing. The nylon rotation rod with the retaining section increased by 50% to ensure durability. These are designed to be changed locally. I find that for golf or batting, such as baseball, cricket, things like that, in sport, many prefer a softer torsion movement because they prefer that swing through and follow through they get with the softer rod. But this is just a personal experience. When looking at the alignment of the TTPro, determine the height you need to cut the pylon. Note the pylon must be vertical, as you see in the diagram on the left-hand side. We do not want to see the pylon either tilted forward or back. Add 12 to 15 millimeters initially before you cut, okay? Because we're typically looking for about 7 millimeters of axial compression during walking from this unit, okay? And then set the unit up 15 millimeters long, get the patient to walk, set your height as you need it, okay, and then cut to the length finally with a hacksaw. The TTPro is offered in two build types. The first one is the pyramid with the 30 millimeter tube attached, or pylon attached to it. The second one, the pyramid clamp, has a 30 millimeter clamp in the distal end, which is good for assessment or for those patients who continually ask for their limb height to be changed, either increasing or decreasing their heel height, because then all you're doing is replacing with any piece of 30 mm pylon. When looking to order these parts, order the style you require, either with the pylon, known as the TTPro PYR, or the clamp for the 30mm pylon, the TTPro 30. Next, check the activity level and weight of your patient. It should be noted the TTPro is only suitable for K4 amputees up to a weight of 100 kilograms. However, other options I will cover later may be better suited for this type of user. Looking at the product specifications, as I said, it's rated up to 125 kilograms, 100 kilograms for K4. The activity level is most commonly used for K2 and K3 users, and for some K4 depending upon their sport. The component adds 317 grams onto the weight of your limb. The build height, you need 135 millimeters of clearance for the PYR, the pyramid version, which has the pylon attached, or for the clampable version, you need 145 millimeters to be able to fit in. The maximum axial compression you will get is 13 millimeters in this unit. And as I say, for normal walking, I'm typically looking for about 7 millimeters or so of axial compression. The torsional range of motion is plus and 30 degrees rotation, which I already mentioned is more than we as able-bodied people can get, and it comes with 2-year warranty. After developing this product, we saw it was commonly fitted with the Blatchford's E-Carbon range of feet, combining the convenience and everyday foot with a high level of energy turn. It also makes them ideal for recreational sports. At this point, it was decided to add an STP, shock and torsional pylon style device, to these feet to maximize patient satisfaction and performance, and I'll come to these next. Each E-Carbon foot from the Blatchford range is based on a lightweight, responsive and durable design, featuring a split toe spring that adapts and conforms to terrain, enhancing balance by improving medial lateral performance. The independent toe and heel, known as our tripod design, works like a camera tripod, conforming to the underlying terrain, and I'll mention this again in a minute, but also provide ground compliance, but also offers axial deflection in the foot. So our STP adapters, when they were added to these feet already had some axial deflection or compression. The tripod system, as you can see in the video below, provides excellent ground compliance. Okay, so improves comfort by reducing the effect that the environment has on stability of the socket. The world is not flat. Everywhere is uneven. The patients have to accommodate that. If they can rely on the foot to absorb the underlying terrain, then they will be more confident and be able to walk better. The further advantage of the independent toe and heel is that it provides vertical compliance. So we already have some of that axial compression from the earlier shock and torsional pylons built in. So this gives you an improved comfort in shortening the limb in mid-stance to prevent a loss of momentum during forward progression of the foot, allowing for an easier rollover and saving energy. So the first version we came up with was the EliteVT. The EliteVT is based on our Elite 2 foot with the addition of a VT unit. Vertical thrust as our trademarked shock and torsional pylon. The Elite 2 already provided up to 11 millimeters of vertical compliance, whereas the VTM that was added to it gave us a further 13 millimeters. Okay, so giving us 24 millimeters of vertical compliance in total. The VT unit also provides plus and minus 15 degrees of axial rotation, which combined reduce shear forces in sockets. The reason we decreased the amount of torsional control was because of the most active patients, as they push off from the leg, excessive torsional adaptability meant that they may not always be able to control the foot, especially in sporting events where you have what we call cutting. You lunge forward onto one foot and then push off from that foot for a rapid change of direction. The reason for building the VT on top of the Elite 2 foot was to give us the benefits of the tripod stability and the axial shortening of the foot, while the E-carbon heel is more durable and offers active response for the more active patients. It should be noted the vertical compliance in the Elite 2 was manufactured in conjunction with clinical practice in the United States. Independent tests were done to compare to the VSP foot, and testing demonstrated that it met the criteria to meet the shock code reimbursement level for the United States. During testing in the United States by independent bodies, they were finding 11.4 millimeters of deflection, which is beyond the standard required to call something a shock absorbing unit in the United States. It should also be noted that we kept the separate heel and toe so they do not conflict. Good. Okay, so the tripod benefits for the EliteVT and Elite 2 foot. The tripod spring orientation uses a 3-point independent contact, allowing excellent ground compliance. Okay, this provides inversion and eversions that patients can feel, not just motion inside the foot shell. So the patient can feel that they're balancing the foot by applying pressure down through these 3 points. The large split in the toe minimizes the possibility of getting debris caught between the toe and wearing out the laminate prematurely. So this is a design feature that we were looking for. Looking at the hanger prosthetic foot study, the MAT mobility series of studies by hangers is a series of analysis of amputees. This is today a 6-part series of studies performed by hangers in the USA. MAT 5V, published in the Journal of Rehabilitation and Assistive Technology Engineering in February 2019, was based about the assessment of mobility of 738 diabetic or divascular patients and one of the largest analysis of prosthetic feet ever. This analysis using a +M prosthetic limb user survey of mobility questionnaire with 12 questions asking to assess mobility scored 1 to 5 by the user. This is converted into a T-score. Choices would be unable to do, with much difficulty, with some difficulty, with little difficulty, and without any difficulty. From the study, the Elite family feet showed second highest in level of mobility for the 5 L code categories being tested above. And it was recorded in the discussion at the end of the paper, if mobility is assessed in isolation, there is no statistically significant difference between the Elite category and the microprocessor feet. And it should be remembered that the microprocessor feet group, it will comprise feet from all manufacturers. Okay, so the EliteVT, designed and engineered energy storing and return foot, okay, looking for excellent ground compliance, independent toe giving inversion and eversion due to the split toe design. The tripod stability mimicking the human foot, where we land on our calcaneus and we have a medial and lateral arch of the foot to give us that 3-point stability. Shock absorption and axial compression as the heel and toe are not connected, so we already have some of the benefits from the shock and shock pylons that we mentioned before. Our feet use a dynamic E-carbon composite. This is blended material of carbon and others. Active toe, the heel is not connected to the toe, maximizing the lever length of the toe spring, storing energy to provide energy efficient gait. And as you see here, the VT spring gives you 13 millimeters axial compression, plus or minus 15 degrees of rotation. The EliteVT is an integration of the pylon within the foot structure to make it possible to angle the pylon relative to the shin axis. Okay. The other advantage of building it down is we could reduce the minimum build height so we had more space. We also trialed different angles of thrust, so by angling that VT unit to see which was the best position for the amputee to optimize the configuration. The final design is an integration of the VT spring paired with the carbon foot, allowing for increased shock absorption at heel strike. This energy is then stored in the heel and released at the correct time, promoting forward progression into mid-stance. Then at toe off, the energy of the foot and the VT spring is released, aiding the forward propulsion of the user and saving on energy. In fitting the EliteVT, the first thing is to bisect the socket to determine the weight line. Accommodate the flexion that your patient has. I would recommend you set the leg up 15 millimeters longer initially. Remember, you're going to have to deal with the axial compression, not only from the VT unit, but also from the foot. And this is a dynamic situation, you'll see this changing. The alignment line is located 1/3 of the foot along from the heel, or 10 millimeters anterior to the pyramid. The E-carbon spring characterization is the same in the EliteVT as the Elite 2 and the Elite Blade, with the addition of 4 categories of axial spring. These categories correspond to the category of carbon spring that was ordered. You can determine which type of spring has been provided by looking at diamond pattern of dots in the spring itself. The dots that are coloured white are the dots used to denote the category. A spring with 1 dot is a light spring, while a spring with all 4 dots is the heavy spring for the most active and heavy users. Just as with the Elite 2 and Elite Blade, it is important to use the correct impact level and not over-categorize the patient's activity. Okay, so we're looking at activity level 3-4, but also impact level when choosing the best for this design. The foot is designed for patients up to 166 kilograms. Activity level K3 and K4. The component weighs 1,000 grams. The build height is 170 millimeters, and the vertical compliance from both the foot and the VT unit and the 30 degrees of rotation range of motion are all built into it. The foot comes with a 3-year warranty. So indications, the foot is intended for patients who would like the energy turn of the Elite 2, but also need a torsional motion. So this is my patient, Charlton. He's a fitness instructor for able-bodied people, among others, at the gym. He teaches sports. On the day we filled this, he actually was holding a weight that you'll see later on this, which is 20 kilograms, that he was swinging up and down over his shoulders as though it was a bag of sugar. And then he went to hand it to one of the girls from marketing department, who'd obviously thought it was very light and went to grab it one-handed. Luckily, we managed to catch it before it hit the floor. It's really intended for the more active patients who need that torsional control and the additional range of motion. Okay, so it's for those patients K3, K4 up to 166 kilograms. So you can see this is the weight. That's a 20 kilogram weight that Charlton's now thrown over his shoulders. That said, almost killed one of the girls when he handed it to them, who didn't really understand what weight was. Contraindications for this foot would be anyone higher than 166 kilograms. People who change their heel height, it's not really intended for them, or people who have frequent exposure to water. Okay, so it is not waterproof, this foot. But he wears his foot all the time, and he goes about, he does all sorts of exercises. Let's see, he's certainly a lot fitter than I am. Moving on, the Elite Blade. The Elite Blade is the Elite Blade VT is the Elite Blade and the Elite VT combined. The Elite Blade VT has the addition of the VT unit with the added benefit of a dynamic pylon. The dynamic pylon enhances ground compliance and forward progression, while the VT unit allows torsion and axial motion to help reduce shear at the socket interface. The VT unit being proximal means that the user is getting these benefits while keeping the weight proximally, makes it feel lighter than the EliteVT. I will in a few minutes let Lee speak about this because he's wore these type of feet. But the thing to note is that this is for the more active patients, routinely involved in manual work or heavy lifting and higher impact sports. Okay. I must emphasize that the balance of the spring system works in partnership with the carbon composite of the foot and pylon, hence the stiffer axial springs than in the other VT units. Again, as for the most active use, the bearing length has been increased and the aspect ratio has been increased. The EliteBladeVT is a cumulation of the previous feet in the Elite product range. The EliteBladeVT has the Elite Blade features with the addition of the VT unit. This combination gives the users maximum energy return with a dynamic pylon and added comfort and smoothness to the VT unit. It's important to note that the additional weight of the VT unit is proximal due to the added length and dynamic pylon. Published in the Military Medicine 2016, military personnel completed a military obstacle course with 3 different prosthetic feet and were asked to give subjective feedback for research at the University of Florida. Highsmith reported 50% of the veterans preferred the Elite Blade over the Veriflex and Reflex Rotate. It should be noted the Elite Blade helped achieve the fastest completion of the obstacle course. Analysis revealed that the metabolic cost, i.e. the energy used during walking, was lowest for the Elite Blades. Additionally, heart rate was at their self-selected walking speed was comparable to that of able-bodied individuals. Skip that slide. Okay, so getting on to the fitting recommendations before we let Lee have a chance to speak. Accommodate the flexion of the patient's limb. Set up 15 millimeter longer initially. Adjust accordingly to the dynamic fitting. This will allow for axial compression of the VT unit and foot. You need to use a fitting jig 941256 for this part. I'll show you a photograph in a minute. The alignment line is located 1/3 of the foot along from the heel. For dynamic fitting, we use the fitting jig. This is a clamp, 2-part clamp jig that clamps around the dynamic pylon and around the VT, which is used for fitting. Okay. Once alignment is complete, cut and drill for delivery. The Elite Blade VT comes in both male and female versions. It's important, however, to note that both the male and female versions are fixed. They do not slide or rotate like the Elite Blade adapters. An existing Elite Blade can be upgraded to the BladeVT, however, using the same holes, as long as you do not need that shift or rotational movement. As with other products in the Elite Blade VT product range, it is important to be accurate in the impact activity levels. The Elite Blade VT is more forgiving than the others because of the motion provided by the dynamic pylon and the VT unit combined. As with other Elite feet, it is recommended to go down a category when fitting a transfemoral. The VT unit is supplied with the appropriate stiffness of spring, just as the Elite VT. The dots listed on the unit are coloured white. The more white dots, the stiffer the spring. The Elite Blade VT is for patients with activity levels of K3 or 4. It has a weight limit of 166 kilograms and also requires enough clearance to allow for 205 millimeters minimum build height. The Elite Blade VT comes in sizes 24 to 30 with a 10 millimeter heel height, and the warranty is the same as the Elite 2 and the Elite VT with 3-year warranty. The VT component allows for 15 degrees of rotation, plus and minus, and allows for 4 or 5 millimeters of vertical travel, just as it does with the Elite VT in normal use. I was going to talk about the patient profile, but actually I think it would be better just to hear Lee talk about his experiences of using this. Lee, you...
Hi, yes. I've had a BladeVT, EliteVT now for a number of years, and have used it from everything from hill walking to completing half marathons a number of times, and also smaller or shorter races. The benefits of the Blade EliteVT for me is, first of all, comfort. I mean, the VT element itself means that I have less tissue damage on the end of my stump. I also get less nerve issues because the torsion takes out that sort of stress that I would normally have on the end of my stump, and it makes my socket comfort more forgiving. Other great things about the foot for me is that I can wear a normal trainer. I can wear one leg throughout the day and then go to the gym without having to change a leg, and be perfectly presentable in a pair of trousers, but then also work well at the gym in shorts. There's other things that it also does. If I'm working and I've got to jump off a high place to a low place, again, it takes out the impact from that. Ground compliance, John has already said, but obviously the 3-point movement that you get around the foot is great every day. So if you hit a cobble or you hit a stone, again, it deflects. The loads aren't straight into your stump. I can change direction really easily, especially if I'm a right leg amputee. So if I want to turn left, I can then pivot across to the left and use the torsion to start off the motion. Again, taking out more stress on my stump. So yeah, so many benefits that I've felt from the Elite BladeVT over the years. Great ground compliance. One of the good things as well is you can just sort of deflect the VT, get over the toe spring, and push off at speed. So it's a great foot for pretty fast acceleration, and really symmetrical when you run as well. So you can run and look, and your shoulders don't dip on the amputee side. So that's a real benefit, and obviously less impact on joints and back and things from that as well. So yeah, it's been a great foot. Also very light. The VT element, with it being close to the stump, doesn't add any considerable weight, which I really notice. So yeah, it's been a foot that I've had for a number of years, and it's pretty foolproof, really.
Thanks, Lee. That gave me a chance to get a drink. Okay, so the EliteVT is intended for K3, K4 users, particularly for those who participate in high activities, especially pivoting type activities, such as the badminton player you can see here, and other racket sports it does really well on. As length is increased, the flex in the pylon increases. Okay, so the taller the patient or the more room you have, the more of a benefit you'll get from this type of unit. It's got to be said, it's not intended for individuals with low activity, because they're not just going to get anything out of it. And it's really not intended for people who need something that can be submerged, frequent contact with water. The final foot I'll talk about today is the EchelonVT, which is actually Lee's day-to-day foot, for any of us who know Lee. Okay, so the EchelonVT. The EchelonVT is using our award-winning hydraulic ankle technology, and then building the VT onto it. The hydraulic ankle technology are anatomically designed to let you navigate a variety of terrains, which allows the amputee to stand and walk more naturally. Hydraulics have been proven time and time again to absorb shock through the socket, similar to the way muscles work, reducing tissue damage, allowing the user to walk more comfortably. And these ankles are designed to make walking possible with less effort, more naturally, and reducing the risk of trips or falls. Listed here are the 6 reasons why an amputee would want to use a hydraulic ankle. Shock absorption, okay, transferring less shock impacts to the limb, allowing it time to recover. The viscoelastic nature mimics that of natural muscle action and joint action, so we have a much more natural gait for the patient, which has been shown to save energy. Self-alignment, increasing stability in uneven ground, whether the patient be standing flat or up or down a hill. The adjustment and control, we can fine tune how carbon composite springs work for each individual by fine tuning how they have that rollover and transition along stance phase. It's about biometric design. We all have an ankle joint that's moving. We have a foot below us that's giving us mediolateral stability, and we're just trying to mimic what you have in your sound foot. And then the positional maintenance that's available with that plantar flexion and dorsiflexion from the hydraulic ankle above these energy storing and returning springs just gives us the ability to control the patient so that when a standard fixed ankled carbon composite foot is always trying to push you forward onto the toe to aid progression, this one will allow the patient to stand comfortably. The other advantage of the hydraulic ankle, of course, is the fact that during swing phase, the foot is held in a dorsiflex position, so it cuts down the chance of catching the toe as you swing the leg forward. This causes less chance of stumbling, and is another reason why the amputee doesn't have to spend so much time looking at the floor. So the EchelonVT is a product that combines the Echelon hydraulic ankle foot technology with the vector thrust. This allows inclusion of rotational and axial compliance on top of what you already get from the foot. The foot is great for the patients who want to participate in outdoor activities such as hiking or golf, and also for patients who have a history of residual limb pain in their sockets, those with bone spurs, things like that. As with other VT units, we have 30 degrees of rotation, so plus and minus 15 degrees from the neutral point. Okay. We have axial compression from the VT unit, which is 4 to 5 millimeters, as well as axial compression from the foot, and we have a typical max of 10 millimeters of axial compression from that VT unit. On top of the benefits already achieved for an amputee by using a hydraulic ankle, the EchelonVT gives additional features. Hydraulic ankle technology in the Echelon has been shown to give you greater load symmetry, reduced socket loading, especially when walking up and down hills, improved gait for the amputee, improved mobility, improved stability, and greater satisfaction. But by adding the VT unit, we add the benefits of short and torsional pylons to this and a very low build height. So we have that torsional compliance and additional axial compliance. Torsional compliance, reducing rotational shear forces in the socket, and the axial compliance making it easier to walk over the foot and absorb shock. The EchelonVT also reduces back pain, particularly at fast walking speeds for these people, by making the limb more comfortable and attenuating or absorbing more shock impacts. It has been shown that the VT unit will actually further reduce the loading rate on the residual limb. Again, as I mentioned earlier on, the importance of these units in reducing this loading rate is the fact that you allow the natural elastic response of the skin more time to take place, so that the pressure being exerted from the ground onto the skin takes longer, and it means that the skin has more time to absorb that and adapt so that you have less tissue breakdown. And then finally, we have the enhanced stability and knee control for transfemorals. Just like the EchelonVT, the alignment is vital in order to take advantage of the hydraulic range. To do this, what we have is we put the ankle on a block, an alignment block, as you see here, put the foot into maximum plantar flexion, and then come down with a load line. So we bisect the socket, accommodate the flexion, and then drop a line. This line should pass 1/3 along the length of the foot, or approximately 10 millimeters in front of the midpoint of the proximal pyramid on the foot. As you can see in the diagram on the right hand side, Unlike the Echelon foot, the independent adjustments for plantar and dorsiflexion resistance have been changed, and they now sit at the posterior of the unit. There is an alignment wedge that we recommend you use for the Blatchford's hydraulic ankle foot, and these can be included free of charge with the order. Okay, using the wedge during bench alignment is critical to achieve optimum alignment and distribution of plantar flexion and dorsiflexion. Blatchford's hydraulic ankles give 6 degrees of plantar flexion. The wedge is at 6 degrees, and this allows for the vertical pylon during alignment or bench alignment. By fully plantar flexing the ankle, as I've already mentioned, positioning it in the shoe and on the wedge, this will eliminate any guesswork of trying to find out the neutral position for when the patient stands up. Moving on, the alignment is an important part of proper function of the EchelonVT, and in order to take advantage of the full posterior to anterior pivot point of 9 degrees of hydraulics, once you've done the bench alignment, don the prosthesis and perform the static alignment. When aligned properly in static alignment, the user should be able to stand with minimum muscle control. Okay? They shouldn't feel that they're constantly teetering about and either being pushed forward or back. To get this to happen, correct anterior-posterior placement of the foot is critical to achieve this. Okay? As seen in the picture, if the anterior-posterior shift is too far forward, the user will be leaning on the plantar stops and the foot will need to be slid forward. If the AP is too far posterior, then the patient will be leaning dorsiflexion stops and it will need to slid backwards. Ordering the EchelonVT is the same as the Echelon, with the added importance of getting the correct user weight to make sure you receive the proper axial spring inside the VT unit. If using a transfemoral, I feel that the ratio may be half a category out. Okay, so if your patient is in the lower half group, then I would always drop a category for the transfemoral patient. Fitting recommendations, activity level K3, the same as the Echelon, but for patients who want to do more, or like Lee, who have higher impact activities that they're involved in. Golfers, hikers, or patients who want to work or walk outdoors activities, and patients with a history of socket pain. Some contraindications include users that weigh more than 125 kilograms, or someone who wants a waterproof foot. And as Lee wears this foot most of the time, I think it would be good to hear his experience of having transferred from a traditional energy storing foot onto a hydraulic foot with a VT.
Sure. I originally had blade feet, which were my full-time feet, and moving to the Echelon and the hydraulic type feet. To be honest, at first I thought they would be less cool and perhaps too heavy for me. But within 10-15 minutes of putting one on, I could see that I could walk really smoothly and naturally. My gait, I mean, I've worked places for a number of years before people have realized that I'm an amputee, because my gait is just perfect with the EchelonVT foot. It's great for where I work because I stand on cobbles which are uneven, so I can get all the torsional benefits. I can fidget around on my feet quite naturally and adjust my ankle whenever I want, and yet I don't get a sort of sinking feeling or any sort of pressure on my tibia throughout the day. It's just great for hill, like John said. I take Ruby, I go up hills in the Lake District on the EchelonVT. Very, very safe underfoot because of the compliance to the ground. And like I say, I've worn them for maybe 8 years now plus. And compared to the eggs I would get from a solid ankle, I don't really suffer from day-to-day back pain. My joints, touch wood, have lasted reasonably well up to now. As an amputee, have 15 years. And it's just been a great revelation, really, to wear the hydraulic ankles and really see the difference. Super natural feet. The way you can sit down, the foot will comply with the ground, so your toes not sticking up in the air. When you go to walk up steps, you've already dorsiflexed slightly, so you don't have to artificially lift your limb to climb the stairs. Lots and lots of little things that I think add up on a daily basis throughout the course of the whole day, make a huge difference to energy levels. So I mean, I'm a great advocate of hydraulic feet, and to be honest, I wouldn't like to think how my joints and my back and my stump would be if I hadn't changed over. So yeah, great experience on the EchelonVT.
Thank you, Lee. Okay, so I really just want to have a quick summary of the evidence of using shock and torsion pylons, STP pylons. So in addition to the actual compression designed in the foot, the inclusion of the VT, or the shock and torsion pylon from Blatchford's element, provides additional shock and torsion compliance. Studies have shown the reduction in energy costs and loading rates, as well as improved comfort. It should be noted that 74% of bilateral users preferred shock and torsion pylons to solid pylons in studies. But the keynote things to remember from this is that we see a decreased energy cost of up to 9% when walking at high speeds. We see reduction in the ground reaction force loading rate of up to 38% during gait, and this is going to improve the socket comfort, okay, and improve the patient's residual limb health. We see improved walking comfort of 70% of users. Okay, it was reported by GARD, and as I said already, 74% of amputees preferred the STP to solid pylons when walking. Okay, and these have been done independently by different people, peer-reviewed and published papers. Lights flashing, almost time. So in summary, in conclusion, what I would like to leave you about the information of axial compression and torque absorbing units from Blatchford's is that for the amputee, they improve the safety. Okay, they reduce back pain and improving patient health. We see improved mobility for the user. We reduce compensatory knee flexion, decreasing joint issues in later life. There's an improvement in residual limb health. And as I presented years ago and has now been followed up by several other authors, this reducing loading rate in the prosthetic limb increases socket comfort, okay, and protects the patient's residual limb. We also have an improvement in user satisfaction and patient preference, citing comfort, and as Lee actually pointed out already, that the ease of climbing stairs is all the reason why the amputees like to wear these type of devices. Before we finish, I'd like to point out our offerings. If you need to know any more information about our VT units, our TTPro, and our range of shock absorbing and shock and torsional pylons, please go to our website. On the website, you will also find a list of clinical papers. Clinical papers will show you a summary of independently published research, where we have, instead of making you read the entire paper, you can just read a one-page summary of the key points from it, what they did, why they did it, and the results they got. We also have an ever-growing range of white papers online. These are intended to be short reads that will give you the key points in a simplified English. They make it ideal for non-clinicians to read, so for maybe your patients, purchasing authorities, anyone who has an interest but maybe does not have the biomechanical or bioengineering background of Prosthetist. Finally, I'd like to thank you for your time. Today, my name is John Ross. Lee, do you want to say thank you?
Thanks, guys. Thanks for listening. I hope it's been helpful, and all the best.
Thanks, Lee. Everyone, thank you. The last time I did this seminar, I forgot to ask on another topic. I forgot to ask Lee if you want to say goodbye. So thank you for your time today. If you have any questions, please feel free to contact me at john.ross, as you see here, at blatchford.co.uk. Don't forget to complete the feedback and the follow-up email. This is very important. We want to know what you think goes well in these webinars, what went badly, and also this lets us know that you require a certificate for either your employer or your continued professional development. Register for our next webinar at blatchford.co.uk webinars. And I'd like to point out that you can find previous recorded version of many of these seminars are now ready for you to listen to at your own time, or to review what was said at earlier presentations at blatchford.co.uk/prosthetics/professionals. And these are free to sit and listen to whenever it suits you. Please connect with us. Contact us through blatchford.co.uk. Follow us, and I hope you enjoyed the webinar. Thank you for your time today. Thanks, everyone.